Welcome back. I am Arup Basu from ClusterMicro Technologies. Today we are going to discuss the singleton pattern. So today we are going to discuss the singleton pattern, but before that we have to discuss something else, that is reflection. Normally Java is a very strict and strongly structured language. You write your classes, fields and methods explicitly and compile the code, and at runtime program follows those predefined rules. Okay. Access modifiers like private, protected and public enforce encapsulation, preventing direct access to internal details unless permission is intentionally given. Reflection changes that behavior. Reflection allows a Java program to examine and interact with itself at runtime. A running program can inspect a class and ask questions as which field does this class contain, which methods are defined here, what constructors exist, what annotations are present, etc., etc. And with reflection, the program can even access private members by bypassing normal access check. In other words, reflection gives Java the ability to dynamically inspect and manipulate classes, objects, methods, and fields while the application is running, even if those members were not directly accessible in the normal code. So this is why reflection is extremely powerful, and also why it must be used very carefully. It breaks some of Java's normal safety and encapsulation rule. Okay, a simple mental model is a normal Java use only what was explicitly exposed, right? And reflection says look inside the object and discover everything at runtime. Say a singleton in Java is a design pattern that ensures only one object of a class can ever exist. Okay, that single object is globally accessible. Think of it like one database connection manager, one logging system, one configuration manager. So you do not want multiple copies floating around. Okay, so in real world, if you see, imagine a country has only one prime minister's office, only one reserve bank, so everyone accesses the same central instance. That is the idea behind singleton. Okay, so if you see in normal class behavior, normally in Java we have car C1 equal to new car C2 equal to new car. You get two separate objects and different memory locations. Okay, but in singleton, what we get with singleton, we have bank B1 equal to bank.get instance and bank B2 equal to bank.get instance. Okay, so both references of bank, they point to the same object. So system.out.println B1 equals B2, it will print true. Okay. And if you see a basic singleton implementation, we have here class singleton, private static singleton instance, new singleton, then private singleton constructor, and then public static singleton get instance, return instance. Okay. So why each step matters here is that private static singleton instance is equal to new singleton, then it creates one object only. Okay, and shared across entire application, and static means belong to class and not objects. Then we have private constructor, private singleton. This is the most important part. Normally new singleton would create unlimited objects. Okay, private constructor, it prevents outside classes from doing that. And then we have get instance. Public static singleton get instance provides controlled access to single object. Okay. If you see the memory view here, instead of obj1 pointing to object A, then obj2 pointing to object B, and obj3 pointing to object C, singleton gives reference 1, reference 2, reference 3, all pointing to one object. Okay, so why singleton is used? So we have various common use cases, say logger, so we can have one logging system, then we have config manager, shared settings, we have cache, centralized cache, then thread pool, shared resource manager, database manager, we have controlled access. So for all these reasons, singleton is used. Okay, so this was a simple explanation, singleton. So earlier version creates object immediately. Okay, but we have a lazy singleton also, which is a better version. So create object only when needed, like we have given here, class singleton, private static singleton instance, private singleton, public static singleton get instance. So if instance equals null, then instance is equal to singleton and return new instance. Okay, this is called lazy initialization. But there's a problem with lazy singleton. In multi-threading, two threads may execute if instance equals null, right, at the same time. So then both will create objects, so singleton will break. So for that we have to use synchronized, like we have shown here. Synchronized will ensure only one thread enters at a time. But now we have a best modern singleton also, Enum. Java recommends Enum singleton instance. Okay, usage is singleton AS is equal to singleton.instance. So its advantages are it is thread safe, reflection safe, and serialization safe, and very simple. Okay. So this was a very simple introduction to singleton. Now let us get into the complex part of it. The OCP exam, it tests 3 singleton implementations: eager, lazy, with double-checked locking, and enum. Each has defined thread safety characteristics and defined trade-offs. Okay, so let us go through all 3. So if you see the code here, so we have private static final database pool instance equal to new database pool. Okay, the instance is created immediately when the class is loaded by the JVM before any code calls get instance. Okay, this is called eager initialization. We initialize eagerly before anyone asks for it. Okay, here static it means that it belongs to the class, not to any instance. There is one instance field for the entire class. Final means the reference can never be reassigned. Once set to the created object, it stays there forever. And private means no external code can access the field directly. Okay, so only get instance provides access. Then we have private database pool. Okay, so the constructor is private. This is the cornerstone of the singleton pattern. Okay, with a private constructor, no code outside database pool can write new database pool. The JVM enforces this. An attempt from outside the class is a compiler error. Okay, so you have taken control of the instantiation. One edge case the exam test, reflection can still break this. Okay, so constructor.set accessible true can bypass the private modifier and call the constructor. The enum singleton, which you will see very shortly, is the only implementation that is completely immune to reflection based instantiation. Then we have public static database pool get instance, return instance. Okay, so this is the single access point. Any code that needs the database pool calls this method. Okay, so it always returns the same object. And then we have to come to thread safety. The eager singleton is inherently very thread safe. The JVM guarantees that the static field initialization is completed before any thread can access the class. Okay, multiple threads can call get instance simultaneously. They all get the same instance reference. No synchronization is needed. So what is the trade-off? The instance is created when the class loads, even if the application never actually needs it. Okay, so if database pool initialization is expensive, opening connections, reading configuration, this cost is paid upfront at startup, even if the pool is never used. Okay, for most application this is not a problem, but if the initialization is very expensive and the singleton might not always be needed, lazy initialization is preferable. So now we'll move to the lazy singleton and double checked locking code. Okay, so we see here private static volatile config instance. So instance is not initialized, so its default value is null. The config object is created only when get instance is first called. Okay, this is lazy initialization, so we wait until someone actually asks for it. And then we have volatile, right? What volatile is? So volatile is, so this keyword is critical and the exam test is specifically. Volatile tests the JVM two things. Okay, reads and writes to this variable are always performed directly from and to main memory. Okay, never from a CPU cache. So second, it establishes happens by relationship. A write to a volatile variable is visible to all subsequent reads by any thread. Without volatile, the double-checked locking pattern is broken. Okay, the reason is very subtle but important. When you write instance is equal to new config, the JVM performs 3 steps. Allocate memory, initialize the object, assign the reference to instance. Okay, the JVM and CPU are allowed to reorder these steps specifically. The assignment to instance can happen before the object is fully initialized. A second thread checking instance equals null might just see a non-null reference to a partially constructed object and return it. The resulting object is in an inconsistent state. Okay, and any use of it causes unpredictable behavior. Volatile prevents this reordering. The write to instance happens after the constructor completes. Okay, any thread that reads a non-null instance is guaranteed to see a fully constructed object. Then we have get instance, the double checked locking pattern. Okay, so first check if instance equals null outside the synchronized block. If instance is already not null, which it will be for every call after the first, we return it immediately. No locking, no blocking. Okay, no contention. This is the first path and it handles 99.99% of calls after the first. Then we have synchronized config.class. We lock on the config class object. If the first check found null, we enter the synchronized block. Only one thread at a time can be inside that block. Okay. And second check if instance equals null inside the synchronized block happens. So why check again? Because between the first check and acquiring the lock, another thread might have actually created the instance. Thread A checks null, it's true. So thread B checks null, true. Thread A acquires the lock first and creates the instance. Okay. Thread A releases the lock and thread B acquires the lock. Without the second check, thread B would create a second instance, breaking the singleton. The second check prevents this. Okay. Then we have instance is equal to new config. The instance is created, volatile ensures the reference is safely published. Okay. The pattern, if we have to summarize, first check avoids locking for the common case. The synchronized block ensures only one thread creates the instance. Okay. The second check handles the race between the first check and lock acquisition. So without volatile, this pattern is broken. The exam will test this. If you see double checked locking without volatile, the code looks very correct but has a very subtle concurrency bug on modern JVMs with aggressive optimization. Okay. Then we move to the block 3 of the code, enum singleton, public enum app config, then instance public void configure app config.instance.configure. The enum singleton is widely considered the best singleton implementation in Java. It is thread safe by the JVM. Okay, so enum constants are initialized by the JVM during class loading with the same guarantees as static field initialization, inherently safe and no synchronization needed, and it is immune to reflection. The JVM prevents creating additional enum instances via reflection. Okay, calling constructor.newInstance on an enum constructor throws illegal argument exception. This is the only singleton implementation that cannot be broken by reflection. Also, it is immune to serialization. When you serialize and deserialize a regular singleton, deserialization creates a new instance, breaking the singleton contract. Enums handle this automatically. Deserialization always returns the existing enum constant. Okay, so no read resolve method is needed here. Then we have public enum app config instance. Instance is an enum constant. Okay. Instance is an enum constant, the single instance of app config. The JVM creates it exactly once. There can never be a second app config instance. Okay. Then we have public void configure. Enum constants can have methods appconfig.instance.configure. It calls the method on the single instance. Appconfig.instance is the reference to the one instance. Clean, readable, and no method call needed to get the instance. Okay. So when will you use each implementation? Eager singleton is used when initialization is cheap and singleton will almost certainly be needed. Okay, it is very simple and clean. Lazy with double check locking, it is used when initialization is expensive and the singleton might not always be needed. More complex but differs the cost. Enum singleton is used when you want the simplest, most robust implementation. It is the default choice for new code. Okay, the only limitation is that it cannot extend a class. Enums implicitly extend java.lang.enum, and though it can implement interfaces. Okay. The exam test all three asks you to identify which is thread safe, which is serialization safe, and which is reflection safe. The enum singleton wins on all three counts. Okay. So three things you have to understand here is that first is private constructor is the foundation of all singleton implementation. It prevents external instantiation. Without it, any code can create additional instances and the singleton contract is broken. And second is double checked locking. It requires volatile. Without volatile, the pattern has a subtle JVM-level bug. A thread can receive partially constructed instance due to instruction reordering. Okay, volatile prevents this reordering and ensures the reference is safely published. And third is enum singleton is the recommended default thread safe, reflection safe, and serialization safe, and the simplest code. Use eager when cost is very low, and use lazy when double checked locking when cost is high and the singleton might not always be needed. Okay, use enum when in doubt. So thanks for your time. If you have liked the video, please share, comment and like it. And our OCP portal is up and running, so you can find it in Java ocp.clustermicro.com. You might like to check it out. Again, thanks for your time. We'll meet in the next video.